into the second method of solving binomial theorem known as Pascal's triangle method. By definition, Pascal's triangle gives the coefficient of term in an expansion. Pascal's triangle gives the coefficient of term in an what? In an expansion depending on the index considered. Much later, I said Pascal's triangle gives the coefficient of term in an expansion depending on the index considered. Alright. Now, here's the idea, please. For our previous example we said, known as general method, when we expand, we need to collect what? Like terms. But for Pascal's triangular method, we don't need to collect like terms. The only thing that Pascal's triangle helps us to do is to give the coefficient of term in an expansion. What's coefficient? If I have 3x and I ask you, what is the coefficient of 3x? The coefficient of 3x here is what? 3. The number before and after in front of an alphabet is called what? The coefficient. So that's the idea. Now note something, please. Note something. Let's start. Here's the idea behind Pascal's triangle. Note this. Just take note of this one. What to do now. Know how to draw it. In case you're asked in JAM or WAEC or perhaps in any exam what to do, you must know how to draw the Pascal's triangle table. Alright. Let's take it this way. 1, 1. Can you see that? 1. Repeat this one. Repeat this one. Let's stop. Take this one. 1. Add this up. I have 2. Put this one down. 1. Let's stop. Put this one here. 1 plus 1 becomes 3. 3. Put this one down. Let's stop. Put this one down. This becomes 4. This becomes 6. This becomes 4. Put 1 down. Next up, take this down. 4 plus 1 becomes 5. This plus this becomes 10. Becomes 10. Becomes 5. Put 1 down. Next up, take 1 down. This plus this becomes 6. This becomes 15. Becomes 20. Right? Becomes 20. Becomes 15. I say this plus this becomes, put this down. This plus this becomes 6. 15. 20. 15. 6. And lastly 1. Just follow this pattern and continue to another destination. I have 6 here. So now what's the idea? Having known how to draw this, if I have a plus b to power of 0, 1 is simply my coefficient. If I have a plus b to power of what? 1, this is my coefficient. If I have a plus b to power of 2, this is my coefficient. If I have a plus b to power of 3, this is my coefficient. If I have a plus b to power of 4, this here is my coefficient. If I have a plus b to power of 5, this is my coefficient. And lastly, if I have a plus b to power of 6, all these here are my coefficients. So take note of all this. Know how to draw this, right? Know how to draw this. Let's start with an example, and let's see how we can expand using the idea of Pascal's triangle. Alright, if I'm told to expand a given term, let's say a plus b squared. Example 1, I'm told to expand a given term a plus b squared using what? Pascal's triangle. Triangle method. So what will I do? What's the idea behind this? Recall when we expanded this using our general method. If you remember, we had a squared plus 2ab plus b squared. Yes. When we did the our previous video, when we did the general method of expansion, we had this. Let's now see if we expand this using the idea of Pascal's triangle. Let's see if our answer will be the same, will be comparable. Now, for Pascal's triangle, here is the idea. Listen. I have two terms here, A and B. Now, note this step. Note this step, please. Put down. Note, please. Note. Alright. The first term takes all the power. The first term takes all the power. I mean this, the first term takes all the power, while the second term is left with nothing. That's the first approach. Next up, number 2, note 2. Reduce A by 1, increase B by 1. You said reduce A by 1, increase B by 1. So, having noted those points, let's apply those points we have noted. We said the first note is what? We have two terms here. You said A takes all the power. So A, if I'm going to expand this Pascal's triangle, that becomes A. This A takes all the power, that is 2. And what? B is left with nothing. A to the power 0. That is my first task. Next up, put a plus. You can see that. We said reduce A by 1. So A, if I reduce A by 1, I have A to the power 1. Likewise, B, increase B by 1, I have A to the power 1. This is 0 plus 1 is 1. Next up, plus it. Reduce A also continuously. Reduce A by 1. That is 1 minus 1, that's what? 0. A to the power 0. Increase B by 1. That becomes B to the power what? Of 2. So, now, you will stop when B has taken all the power. You stop at that point. Here's the idea. If A takes all the power here, and B takes all the power here, you stop. So, you stop. Next up, what do I do? A to the power of 2 is what? Is 2 into B to the power 0 is 1. From the idea of zeroth law of indices. The zeroth law of indices states that anything to the power of 0 is 1 except 0. Except 0. There's an exception in the zeroth law of indices. So we said x to the power 0 is 1 except 0. So I have 1 here. Plus x to the power 1 is what? A. B to the power 1 is B. Next up, I have plus a to the power 0 is what? A to the power 0 is what? Is 1. I have 1. B to the power into B squared. I have B squared. So if I have A squared plus 1 times 1, I have A squared plus AB plus what? B squared. So we have not finished solving this. If you recall, when I defined Pascal's triangle, I said it helps to give the coefficient of 10 in an expansion. That is, there is a coefficient here, a coefficient must be here, and a coefficient must be here too. So, now at this point, applying Pascal's triangle, we said we have what? A plus B to the power of what? 2. In the coefficients, what was my value when I did the coefficients? A plus B to the power of 2, to the power 2. What was the coefficient? You know, we said we have 1, we have 1, 1, we have 1, Pascal's triangle for any term to the power of 2 becomes what? 1, 2, 3. That is 1, 2, 1. 1, 2, 1 is what I'm going to be using. So I will name this. Now, it simply means all this. They stand in front of all this. That becomes 1 into a squared. I have 1 into a squared plus this 2 into ab plus this 1 into b squared. So at the end, I'll be having 1 times a squared, that becomes a squared, plus 2 times ab, that becomes 2ab plus b squared. Here is my answer after expansion using the idea of Pascal's triangle. If you observe, when we use general method, we had the same answer as our previous example. So here is the idea behind Pascal's triangle. Let's take another example and see how we can solve it using the idea of Pascal's triangle. Let's solve this term here using the idea of Pascal's triangle. This is example 2. When we solve this in our previous video using general method, we had a cube plus a squared b plus a b squared plus b cube. When we expand this is what we are having using general method. Let's now see if we apply the concept of Pascal's triangle, and let's see if we are not having the same thing. So what do I do, please? Listen. We said for Pascal's triangle, I gave you a 2 parameter to solve it. The first task was what? We said A takes all the part, while B is left with nothing. That becomes A takes all the part, that is 3. While what? B is left with nothing. So plus reduce A by 1, that becomes A. 3 minus 1 becomes 2. Increase B by 1, that becomes B. This is 0, 0 plus 1 is what? 1. Next up, plus the same procedure, that step 2 continues. That becomes A. Reduce A by 1, that becomes A. 2 minus 1 becomes what? 1. Increase B by 1, that becomes B to the power of what? 2. 1 plus 1 is 2. Next up, I have plus. So note this answer, please. Note this answer. So we said A takes all the part, while B is left with nothing. Next up, we said reduce A by 1, increase B by 1. That same procedure continues. Reduce A by 1, increase B by 1. Next up, reduce this same A by 1. I have A to the power of 0 because 1 minus 1 is 0. Now increase B by 1, B to the power of what? 3. 2 plus 1 is 3. I said you stop when the last term take all the part, you stop at that stage. Now, having considered all this, next task is that is equal to, I have a cube, b to the power 0 is what? We said in our last example here now, we said n to the power 0 is what? 1. That becomes 1. So, plus a squared into b to the power of 1 is what? Is b. N to the power 1 is that thing. So, plus a to the power 1 is a into what? A squared plus a squared. A to the power 0 is what? Is 1 into b cubed. So my next task now is what? 3 cube times a cube times 1, that becomes a cube plus a squared b, that becomes a squared b, that becomes a squared b. A squared times b becomes a squared b plus a times b squared becomes a b squared plus b cubed. I have this as my expansion. So we are not done at this stage. So applying what? Pascal's triangle coefficient. Rather, applying Pascal's triangle coefficient. That becomes what? Coefficient. So I get what? For anything to the power of 3, what was the coefficient? Let's do it here. I have 1 plus 1 plus this is 2, 1. I have 1, 3, 3, 1. So this is for 0, this is for 1, 2, 3. So let us for 3. The coefficient is what? Is all this. So you must master this. So my coefficient there is what? It's going to be what? 1, 3, 3, 1 is my coefficient. So now I need. Now I what? Compare. That becomes, take this one is equal to, take this one into the first term, a cubed, plus, take the second term here, 3, into the second term here, a squared b, plus the second term here, the third term is 3, into the third term here, ab squared, plus I have 1 into the last term, b cubed. So next up, what do? 1 multiply a cubed becomes a cubed plus 3 times a squared b, that becomes 3a squared b, plus 3 times a b squared, that becomes 3ab squared. So plus what? B cubed. If you observe, the answer I wrote here was the same with this. So here is the idea behind Pascal's triangle of Binomial Theorem. So here is how to solve question using the idea of Pascal's triangle. So let's take another example 3, and let's end this Pascal's triangle and move to combination method. Taking example 3 on Pascal's triangle, since our previous class and this class, we have been considering a plus b to the power of 3, 2, 4. What of if you are having a term attached with x or y being raised to a value? How do you go about it? If I have 2x plus let's say 3 y to the power of 2 being raised to power let's say 3, for instance, we are told to expand this using Pascal's triangle. What do? Apply the same concept, please. Apply the same concept. What's the idea? We said the idea was that what? Pick out the first term. That the first term take all the power. My first term here is what? 2x takes all the power. That is 3. And what? The second term is left with nothing. That becomes 3y squared is left with nothing. Next up, plus. Now, to reduce the first term by 1, that becomes 2x to the power of what? 3 minus 1 becomes 2. This second term increases by 1, that becomes 3y squared. This is 1. 0 plus 1 is 1. So, plus, next part is what? To reduce the first term here by 1, that becomes 2x into 1. Next up, increase the second term here by 1, that becomes 3y squared into 2. Lastly, I will have plus, reduce the first term by 1, I have 2x to the power of 0. Increase the second term by 1, I have 3y squared to the power of what? 3. I said we stop when the last term take all the power. So I stop at this place. Let's start. What do I do? So I know very well, if I recall indices, if I have 2x to the power of what? 4. This 4 will affect this 2 and affect this x. That becomes what? 2 to the power of 4. This 2 will have this 4 on top, and this x 2 will have this 4 on top of it. So 2 to the power of 4 is what? 16 x to the power of 4. Here's my answer. So I will apply this concept throughout this. So take note of this concept, please. Next up now, I know very well that becomes 3, and that becomes 2 to the power of what? 3, x to the power of what? 3. I'm done with that. Into 3 to the power of 0, y squared into 0. I have this. Instead of writing, this is 2 already on y. So the bracket of what? 0. I have this. Right? What's my next task? That becomes plus, I have this 2 to the power of 2, x to the power of 2. These two will be affected to 2, as we said previously. So this is 1, this is power 1, y is power 2 into 1, because 2 is there into 1. I'm done with that. Plus, this is 1 here, 2 to the power of 1, x to the power of 1. I have this into, this is 3 to the power of 2, y to the power of 2 already into 2. So I have this. And lastly, I have plus, this is 2 to the power of 0, x to the power of 0, right? And lastly, we have 3 to the power of 3, then what? Y to the power of 2 already, 2 into this 3 we are considering, and break it off. So I have this. Next up, 2 to the power 3 is not 6. Please take note of that. 2 to the power 3 is not 6. Rather, is what? 8. Alright, what do I get? There becomes 8 x cubed into, this is 1, this power 0 is 1, y squared, this is 0, right? It's 1, plus I have 2 squared is 4, x squared, right? Into, this power 1 is 3, y squared 2 minus 2 times 1 is what? Y to the power of 2, right? I'm done with this. Let's go to this. Plus 2 to the power 1 is 2, x to the power 1 is x, into 3 to the power 2 is 9, y to the power 2 times 2 becomes 4. I'm done with that. I'm left with plus 2 to the power 0 is 1, x to the power 0 is 1, the 1 is what? 1, into my last term, 3 to the power 3 is what? 27. So, and y to the power 2 times 3 is what? 6, y to the power 6. So I have all this. So what about let's approach? Multiply them. I have 8x cubed plus 4 times 3 is 12. That becomes 12x squared y squared, right? Plus 2 times 9 is 18, right? X y to the power of what? 4. This x, y to the power of 4. This times 6, I have 18. Plus 1 times 27, y 6 power of 6. That's 27, y to the power of 6. So after this, I find Pascal's triangle coefficient. So for degree 3, that becomes 1, 3, 3, 1. If I'm not mistaken. I haven't got to this stage, but let's start now. These are coefficients here, right? That becomes this 1 into 8x cubed plus, I have 3 into the second term, 12x squared y squared, right? Plus, I have 3 again into the third term, 8xy to the power 4. Plus last time is 1 into, plus the last term is 1 into 27y to the power of 6. So I have that. Next up, 1 multiply 8x cubed. That becomes 8x cubed plus 3 times 12 is 36 x squared y squared. Plus, if I multiply that, I'll be having 54 x to the power of y to the power of 4, and lastly 27 y to the power of 6. Here is our answer to that question after applying Pascal's triangle. Now, next video we'll be considering the last method of Binomial Theorem, known as what? Combination method.